everyone. My name is Kolja Kuse. I'm from Germany. I'm a graduate electrical engineer from University of Aachen in Germany, and I started my my working life in the computer industry. I was mainly involved in sales and installation of supercomputers. I was working for Cray Research for a couple of years in Munich. Then I joined NEC Corporation with their supercomputer division and installed, together with my colleagues, a large supercomputer at the Hamburg Climate Computing Center, where Klaus Hasselmann, who got the Nobel Prize in Physics, was doing his climate modeling work, and we made sure that he got the right computer to prove that climate change is something that mankind has been causing, and not the sun or other ideas where all these temperature increases come from. And at the same time, I was trying to help my wife to design a new kitchen, and she said, "You are, as an electrical engineer, why can't you make a better kitchen that is easier to clean?" and so on. We had this hob, this gas hob, and she was always had a lot of work to clean it up because I was too busy selling supercomputers. And I said, well, there may be some ideas. I will think about it. And we came up with a neat and seamless working top of granite. And at the time, there were induction technology was involving, and we put some induction coils underneath the granite. And that really worked from the beginning, but only up to a temperature of 70 degrees, because then the neat granite tabletop got, what did it get? A crack. We couldn't go beyond 70 degrees, and all the plates, different stones we used were cracking. So then I was sitting in a plane, and they hadn't time enough to clean it up from Hamburg back to Munich, where we live, and they couldn't clean it up. And I found a newspaper article about carbon fibers and the amazing properties of carbon fibers, that carbon fibers is shrinking when temperature goes up. I said, yeah, this could be something to stabilize the granite plate. And we did it, and from that day on, the plates didn't get any cracks anymore. So we said to ourselves, this is something new, and we may further work on this. And then we patented the idea, and 5 years later, my wife said, do you still want to use this patent? I'm not going to pay for that anymore if this is just costing money. And I said to myself, we need to do something. We need to do something new, and maybe this material can help Klaus Hasselmann's dream to reverse climate change. And we came up with this material. This is, we call this carbon fiber stone. This is made of granite. So we machined the granite plates down to thin plates of 2 to 3 millimeters, coated it with carbon fibers like the kitchen tabletop in our kitchen. And we found the amazing properties of stone are that stone is becoming flexible once you utilize what is in the school book. The E modulus of granite is about the same as that of aluminum. So no one has thought about before what this could mean. We found, then we went to a fair, some first customers to use this in the ski building, and that is what we actually did. We built a first ski with the materials, and after 5 years of usage of the ski, we cut the stone off, which was wrapped around with carbon fibers, and there was no single crack in the stone, even after heavy skiing and bending of the stone material. So this is really a new paradigm in material science. So we cut stone slabs with diamond ropes. The crystallic structure of the stone is compressible in volume. That is what we found out without ruptures or fatigue. Within certain limits, we did 1 million load bending cycles with pieces like this. This is a gabbro from Africa, and it didn't lose any stiffness. It had no rupture, no fatigue at all. So steel after 1 million bending cycles up to its elastic limit would lose, for example, like 5% of its stiffness. This material is not reacting to any of such load. The other point is that granite has about the same specific weight, the same gravity like aluminum. So we are talking about a lightweight material here that is in the range between carbon fibers and aluminum. So this really represents a new paradigm and major breakthrough in material science due to the incredible mechanical advantages of the stone over most other materials and at a much higher longevity. So how can we move this further? Okay, it works. So here you can see what we can do with the stone. This is a 3 millimeter thin CFS sheet. As a base material covered with a carbon fiber. Only on the downside, you see the stone surface on the other side. And the flexibility of the material is adjustable by the strength of the carbon fiber, meaning the relation between the thickness of the carbon fiber and the stone layer. Then I visited some of the climate change conferences and wanted to find out what we could do with this material eventually to tackle climate change issues. And we showed this material at the climate change conference in 2007. And we had a little booth there, and suddenly a student from Saudi Arabia was standing in front of me and said, "What if we could do this carbon fiber from CO2? And your material, the stone, is made by nature. We just have to cut it with electrical energy. There's no emissions involved in this anymore." I said, "Yeah, this is a fantastic idea." The guy jumped up about 1 meter, got up to speed. "I need to tell this to my professor." He was gone. I never saw him again in my life, but I said to myself, now I know why I went to this climate change conference. And we started working on the idea to make the carbon fibers from CO2. I met Professor Brück at the Technical University of Munich, and he said, "We have a large architect center that we drive together with Airbus, and I can help you, we can do it." And then the Green Carbon Project was initiated and funded with 7 million by the German government. And we have proven that we can make carbon fibers from algae oil. That means the algae is eating the CO2 and converting the CO2 into oils. Within this project, we had the chance to develop different geometries like an I-beam. And you can see here still the stone is keeping its promise. It is flexible even in a structure like this. It is 2 times lighter than a comparable beam from steel. We also use this, I have some samples here, to use it as rebar in concrete. For example, we can, it's ideally suitable for CO2 enriched concrete to replace the rusting steel. And you can see that we can even flexibilize concrete with this for earthquake-safe buildings, for example, and so on. This, by the way, is not an American garage. It's located in Germany, but we thought it would be a good idea to show this in the US because you like the garage of initial works. We built beams like this. Again, I did something for my wife. This was the funded project, and then this was funded by the German government. We built some rectangular beam and built a very nice and neat terrace in front of our steep slope in front of our house, where we had big problems to build something from concrete. And you see here very thin, 10 millimeter thin stone slabs from the limestone, which is the base material for cement making. We use a stone as it is. It is coated with carbon fibers. And what is... Yes, sure. We talked about that yesterday. We can actually realize any kind of geometry with this. University of Aachen came up with the idea to build a rotor blade instead of using glass fiber. This is a downscaled prototype that we built with them. This project was just finished 2 months ago, and it was tested. It is has much higher longevity than other structures. And together with the Federal Ministry of Economic Affairs and Climate Action, we initiated another project which is still ongoing to make railway sleepers, which is a large scale application. This guy, so I have 10 million load reversal without any cracks. A concrete sleeper dies after 3 million. And we needed to stop the test without any rupture because the immense cost for the testing went already up the electrical power to some 20,000 euros. And didn't make any sense to test this thing anymore because it wouldn't break. The other thing we are developing here is a bridge, an 18-meter pedestrian bridge. And then we got another call from the German government to be included in the CDR Terra project, land-based CDR, carbon dioxide removal. And within that project, we developed an old dream to really build a house wall, which is highly carbon negative from our materials. We use biochar as insulation material inside. It's a very light type of biochar, together with the carbon negative carbon fibers and the gabbro stone powder that we create while cutting the slabs. We get a high carbon negativity of about minus 59 kilograms per meter house wall, while a house wall from concrete has 89.
Wait, one more presentation got to fit in here in this session.
I'm finished now.
Okay.
Yeah,
okay.
But I needed to show the house wall because this is really highly carbon negative, and it comes at the same cost than a wall of concrete. The gabbro stone powder is the best in absorbing CO2, about 450 gram per kilogram of gabbro stone powder. And if you were to build 400,000 flats in Germany, this would sum up to 10 megaton of carbon dioxide removal per year in Germany. And a global view on that, we could capture at least 4 gigatons of CO2 per year if we would replace all steel and cement and concrete. We have patented all of this. We are worldwide active. And now we are looking for money from investors because we need to scale this up worldwide and develop applications in different countries. Thank you very much.